Okay guys, let's continue on with number 2. We're graphing this system of linear inequalities. For my top inequality here, I see it has a slope of -5, 6 and a y-intercept of 3, and it's going to be a solid line because it's equal to. So I'll start with my y-intercept at 3, and I'll go down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6. Let's see if I could do that opposite way. 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5. I can fit it up there. So there's my first line. Let me do it this way, making it solid because it's equal to my boundary line. And now we want all y values less than that line. So that means I want all y values below this line. So now let's solve the second equation for y so that we can put it in slope-intercept form. So the first thing I'm going to do is subtract 3x. -6y is greater than -3x. You can keep that plus 0 there if you like. You don't have to. Now I'm going to divide each term by -6 in order to isolate y. So that's going to give me y. Now keep in mind I divide it by a negative, so that's going to flip my inequality sign to be less than 1/2 x plus 0. So I have a y-intercept of 0. A slope of 1/2, a y-intercept at 0, and this is going to be a dashed line because it's not equal to. So I'm going to start at 0, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And then I'll go back 2, down 1, back 2, down 1, back 2, down 1, back 2, down 1. And I'll get a dashed line through there. Now we want all y values less than that line, so I want to shade below that line. Now keep in mind the solution is the part where it overlaps in between those two lines. And I could pick a point, maybe let's say here, and that would be 0, -2 is a solution. But we can see that there are an infinite amount of solutions that you can choose from this system of linear inequalities.